Hi everyone, welcome to week 13. So for this week, we're going to start with some on-screen notes, and then I've also got an example of a song by Webern for us to get into, and we will get acquainted with some 12-tone theory. So let's start by making some notes about that. 12-tone composition. Using all 12 pitches in a row before repeating any. Using other versions of the row. We'll define the row in just a second. Also known as dodecaphonic music. Some composers that you might associate with this, especially, are Schoenberg, who we talked about in that reading. I wanted you to read that before we got to these weeks because I wanted you to think about this sort of like late tonality that we were studying back then and the sort of transition to serialism and to post-tonal music with, sets and things like that, and then this 12-tone music. And I wanted you to have a sense of like where Schoenberg was kind of coming from with it and the great care that he had for music in general and for this kind of composition. So we think of Schoenberg as being the kind of ringleader of the Second Viennese School. So he's kind of the first one. When I say Second Viennese School, that suggests, right, that there is a First Viennese School. And the First Viennese School would be Haydn, Mozart. So he, thinks of himself as continuing this tradition. And also these composers lived in Vienna for a while. So that's part of why we call them this. So Schoenberg is the teacher then of two other composers, Berg and Webern, and many other composers besides those two, but these three together are kind of the primary group that we call the Second Viennese School. And we're talking, of course, about the beginning of the 20th century up through about World War II when they're all living there. Webern was actually shot by an American soldier by accident at the end of World War II after it had actually technically ended, and so he didn't live beyond that. Berg did, and to my knowledge, he stayed in Europe. And Schoenberg, we've talked about, I think. Schoenberg immigrated to the United States and lived in Los Angeles for the last several years of his life. He immigrated there before World War II actually had fully begun in terms of the American involvement of it. He did that in no small part to escape the Holocaust because he is of Jewish descent. And he could see what was going to happen. So let's get into some of the actual terms that we'll be using. I've got some definitions. The first definition I want to give you is that of the row. It is an ordered grouping of all 12 pitches stated in a piece without repeating any. So when I refer to the row, I'm talking about this, like, statement of all 12 in a row, and the intervals are also ordered by default. And I'll show you what I'm talking about when we actually look at a row as an example. We will use the term prime, the first and dominant version of the row in a piece. We usually will label the first row that we encounter a prime row and say that it's sort of a clear and relatively easy to follow version of the row that happens in a piece of music, and so that's why we call it prime. Technically, it's not the same as like having a tonic chord or something where it's consistent and you always know, but prime versions of the row can be transposed and end up with another prime version of the row. Now, if you've done this before, you may have started whatever you call P0 is usually the first and easiest to find version of the row. You might have called P0 whatever was the first and easiest to find version of the row, but here we're going to say that starts on C. P1 starts on C sharp, following the order of pitch integers, right? Whereas C is 0 and 1 is C sharp, 2 is D, etc. So you may have done this differently, where P0 is the most kind of like dominant, important version of the row, and that's the one that you called P0 no matter what the first note was. But we'll always label P rows according to their first pitch. Another version of the row would be its inversion. And it is like it sounds, inverted version of the prime row according to intervals. And I will say that this is vertical top to bottom on the matrix, which we will of course do. I don't want to start with it. Let's say also horizontal left to right on the matrix. In addition to inversions, we could also have a retrograde, which is horizontal on the matrix, moving right to left. Another way to think about this is that it is the prime row backwards. So a retrograde is like it sounds. We're just going to do the same row, but we're going to start at the back and move to the front. And then, of course, one more would be the retrograde of the inversion. And that would be retrograde of the inversion would be when we start with the inversion and do that backwards. Inverted version of the row backwards. So this will be vertical bottom to top, and then I think we have covered all of the 4 cardinal directions that can happen in a matrix. This is our I wanted to have a written out definition of it, and I will absolutely show it to you as well in a matrix. But to start with then, let's go ahead and look at this Webern piece to get an example of a row from a real piece of music. Okay, so here's our Webern piece, and if you haven't already, please go ahead and hit pause and go listen to this several times. Don't just listen to it once. And I wanted to also just mention that I'm getting a lot of my particular kind of details for this analysis from a book called, I'll just say for reference here. First, I'll tell you who it's by. Joseph N. Strauss, a living music theorist who teaches at the City University of New York Graduate Center. Introduction to Post-Tonal Theory. I'm using the 3rd edition, but there is a newer one as well. So this is like a small white book that you may have been asked to buy for a class in undergrad. And I do think that it's a handy reference tool. So I didn't ask you to buy it, but if you want to know more, or you feel like you just need something else to explain this that you want to read on your own time, I would highly recommend it. I'm sure you can get it from the library, or I'm sure you can get a cheap used copy of it on the internet. Okay, so that's partly where I'm taking my analysis from for Wie bin ich froh, which is this piece. It's one of the 3 songs. As you can see, there's a handy translation here with poems by Hildegard Jona. So even though there is a piano part, and it is also 12-tone, we're going to start with the voice part because that is the clearest statement of the row that we get at the beginning. It's clearer than what you see here in the piano, and it clarifies how to make selections about the order of these pitches when they happen at the same time. So it's a handy place to start here with this voice part, a vocal piece. So we'll start here with this row. And a good thing to do, I'll just say rows from wie bin ich froh. Oops, there we go. A handy place to start is just to list the notes, and we want to list them carefully in the order that they appear in the piece. So listing these notes, and I'm going to list them first as, no, I'll list them as numbers the whole time, as integers. So we start with 7, we get 4, remember D sharp is 3, 6, and then let me scroll down. C sharp is 1, F is 5, D is 2, 11, or excuse me, B is 11, which we're going to call E, 10 for B flat, 0 for C, 8 for A, excuse me, 9 for A, 8 for G sharp, 7 for G, 8 is for G sharp, and that is all 12. So if you aren't sure, you can always go back and count. Okay, take a look at what you've got here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 0. So there's all 12 pitches. Because this row starts, we'll say voice part measure 3, beginning in measure 3. Because this part starts on 7, and I'm saying that I'm calling this the prime row because it is the first row that's stated in the voice part, and that to me makes it like kind of the clearest statement of the row at the beginning of the piece. This is a subjective decision. You could argue that it needs to be different, but I think that this makes sense. Because this is a prime row and it starts on G, which is 7, we're going to call this row P7. One thing we can also do is just take note of the order of intervals that happen in between them, in between each of these notes. I'm going to note that down here on the next line. I'm going to give myself a little more space between each one so that I can have space on the second line to note how far apart they are. Okay, so at the beginning, for example, we start, the difference between 7 and 4 is not 3, right? Think about it in terms of the clock face diagram. I'll take a second and pull that up for you here. So here's our clock face diagram, just to refresh your memory. And we want to find the intervals between these different things. So from 7 to 4 backwards is 3, but we want to go clockwise. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the actual difference between those two. So there's 9 between 7 and 4. Just use that little kind of caret to show that that's what I mean. Between 4 and 3 is not just 1, right? You have to go clockwise. Going clockwise, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or let's go with E. From 3 to 6, luckily, is clockwise already in chronological order, so that is already 3. Oh, I forgot I said I was going to, oops, no. I'm just going to do that to show that I'm talking about those. Okay, from 3 to 6 is already 3, and keep in mind this is what I mean, like the distance from here to here is 9, from there to there is 11, from there to there is 3. I'm not kind of drawing this very well, but I think you get the idea. So from 6 up to 1 is over here, so we go 6, 1, 2, 3, 4, 5, 6, 7. So that would be, oops, 7, like that. And then we have, here, I'll try to give myself a little more space even between each of them so that I can draw things. And then from 1 to 5, again, chronological order already, so that's fine. There's a difference of 4 there, or an interval of 4. From 5 up to 2, again, we're going to go, here's 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's another space where that's true. From 2 up to 11, that one is already in chronological order again. So here's another 9. From 11 to 10, now here you can sort of think, okay, well, from 4 to 3 was 11 steps, and it's like we're going back 1, but actually we're calling it 11 steps in chronological order. Then from 11 to 10 works the same way. It's also 11 steps if we're going in chronological order. I'll show you what I mean by that. Again, here's 11. To get to 10, we have to go all the way around. So from 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's what I mean by that. From 10 to 0, just 2. From 0 to 9 is actually just 9, like it seems like it would be. And from 9 to 8 is another of those times when we have to go, it's not just 1, it's a difference of 11 because we have to go all the way around. So there's 11 again. And I'm just going to take a second and draw all of these because this is how it actually showed the intervals between these pitches with these little thingies to show that like this is the distance between those two. Just to be clear, the numbers with these little carets beside them are what we call ordered pitch class intervals. Those are the things that actually create the row. So if we started the row on a note other than G or a note other than 7, if we started on 4 or something, it would still have this pattern of intervals. And that's how you could tell, oh, it's still a prime row because it's doing that same thing. It's got that same set of intervals there. Once we've done that, I think it's helpful then to sometimes look at subsets within the row. And to do that, I'm going to start putting these notes on a staff without any rhythm or anything, just to kind of look through them. So let's go ahead and start putting the notes of the row on a staff so that we can look at it kind of in order. We go from G down to E. We go up to F sharp, or excuse me, up to D sharp from there, way up here. And up to F sharp from there. Now we could, though, theoretically, like, move it down, and that wouldn't necessarily be a bad thing. We might see versions of the row where things are, where the octave register has been changed. In any case, let's keep going with that. After F sharp, then in the next bar, we get C sharp. My bar lines don't actually go with the bar lines of the piece, even though they started to. Let's make that D natural, just to be clear that it's D natural, that this is F natural. Then we have B natural. Then we have B flat. I'm going to take the bar lines away once I'm done here. And then we have C natural, A, and G sharp way up here. Oops, that's not right. So now we have our row. It has stems, which is unnecessary, but in any case, now we have our row spelled out on the staff here, and it might be a little easier to see different relationships that happen kind of within it. So I think it can be helpful to break the row up into tetrachords and trichords to see what's happening inside it. So look at the order of trichords, groups of 3, and or tetrachords, groups of 4, to see what's happening inside the row. We could even say and or hexachords, groups of 6, to see what's happening inside the row. And I like to have it like this so that I can just easily reference it as I then go back to my set theory calculator. So let's reset that. Okay. I think it's helpful to just sort of label them as we go. So G, E, D sharp. There's 014 in case you weren't sure. Let's see if I can then... So I went ahead and imported a version of that image to my Word document so that I can edit it here rather than on MuseScore, which is just less cooperative. So anyway, I'm going to then draw little brackets to show, you know, what the different trichords are to start with. Just to kind of get going with that. And then I'll note up here, if I turn that off, that the first one is 014, we said. And then our next one, let's see what it either has in common or doesn't. We've got F sharp, C sharp, and F. Real quick, make your prediction. Do you think it will be 014 or something else? Aha, it is 015. Similar, you could tell that there's a half step between F and F sharp. And then the widest distance is kind of what we need to take into account, which would be from F sharp to C sharp. Okay, so then here, let's note that this is 015. You could tell it has a half step, so you might have thought, oh, it could be 014 again. And so then let's do another one. We'll try this one and see if it's any different. D, B, and B flat. Oops. D, B, and B flat. We've got 014 is back. So we have another 014. And then if we reset that again, we've got finally C, A, and G sharp. I keep doing that. C, A, and G sharp. 014 again. So note that 014 happens 3 times within the sort of breakdown of this row. And sometimes you could even have a row that would be all 014. It would just have a different order of pitches than this. And that's interesting because if a row is made all of, like, can be broken down into all of one set class, it's going to have a distinctly different sound than this kind of row. So let's pick a different color now. Let's try this kind of light green color and look at the tetrachords, of which there are 3. And there. Okay, and now I will move my actual cursor back here. So let's go back and do the same thing. We've got G, E, sort of move that up a little bit. Okay, G, E, D sharp, and F sharp together. We have 034 now if we combine those. And for this one, C sharp, F, D, and B. 0236, so very different. 0236. Not at all the same. This is part of what I think of as just sort of like an initial inventory of what's happening in this piece. Is like we've got this row, and here are some of the qualities of this row, and it's interesting to see if it has any kind of special ones. 10, 0, 9, and 8. 0124. So no kind of larger relationships between that particular group of tetrachords. Now what I want to do is kind of use another color and look at the hexachords too. How about this kind of pink? That looks fun. For tetrachord or for hexachords, I'll just go like this and we'll divide right down the middle. Boop. And there. I'm very good at drawing, as you can see. Okay, and let's move this here. For this hexachord, what have we got? To start with, we have 7, 4, 3, 6, 1, 5. Oh, 1, 2, 3, 4, 6. Very dissonant, right? Oops. And there. Okay. Now let's see if we go to this one, if it has any really different qualities. We've got 2, 11, 10, 0, 9, 8. And look, it's the same actually. So that's kind of cool. There's one way to kind of see if there's interesting relationships going on within the row, and just to get a sense of how the composer chose to order the notes. So for one thing, you can see how thinking about how the intervals are ordered and how these like subsets within the row are ordered gives the composer a lot of control over the amount of dissonance that's happening even within the row. And then if you combine the row with itself, you could see like, well, here are places that are potentially very, very dissonant, and just gives the composer a lot of control over the sound of the piece as a whole. Okay, so that's all we're going to do with this row for the time being. And in the next video, I will talk about how to make a matrix and do some other kinds of manipulations with row forms. So I will see you then.